So here it is, the kind of problem that has sunk a million algebra ships in the past. And we'll talk about why it sinks so many people's ships in a moment. But in the problem, you're being asked to take a power of a polynomial. Specifically here, we're being asked to take the second power, to square a polynomial that has two terms, a binomial. U minus 4 is our binomial, which we're being asked to square. So what's our strategy going to be? Our strategy begins with not doing something. Specifically, don't do what you're probably tempted to do when you first look at this expression. What are you tempted to do? You're tempted to do that thing that lands algebra students into the purgatory of lost points. So here's what not to do before we talk about what to do. So you see this expression, u minus 4 squared, and you say, well, on the outside of these parentheses is an operation, and I'm used to distributing operations outside of parentheses to every term inside the parentheses. So why don't we just square the 4 and square the u and be done with it and wash our hands of this problem? U minus 4 squared is u squared minus 16. What's wrong with that? Well, we'll see what's wrong with that in a minute. For now, suffice to say that this doesn't work. The reason that that 2 does not distribute across the parentheses is that 2 is not a multiplication or division. That 2 is an exponent. And that exponent layer of the cake is not actually in contact with the addition and subtraction layer of the cake. We can't distribute a power across addition and subtraction. So that's what not to do. Whenever you see a power outside of parentheses, you better stop yourself for the moment and step back and say, can I distribute this power? If there's any addition or subtraction inside the parentheses, the answer is always no. So don't do what you're tempted to do. So what should we do instead? Well, again, anytime there's a power happening to a multi-term quantity, so here it's a polynomial, u minus 4, the strategy is always to not see the power as a power. Strategy should be, again, not to distribute, but instead to rewrite. So the way we're going to get around this, one of the most common errors in all of algebra, is to rewrite this power, this squaring that's happening here, as a multiplication problem instead. And once we've rewritten it as a multiplication of polynomials, then we know what to do. We can distribute multiplication over addition and simplify, just like we did in the previous example. Helpfully, the statement of this problem also gives away that strategy. It'll say rewrite without parentheses. But even if the problem doesn't state it explicitly, I'm going to expect you to know that this is what must be done every time you try to take a power of something that has multiple terms. So what does that rewriting look like? We just have to remind ourselves that to square a number is to multiply it by itself. So u minus 4 squared is really just u minus 4 multiplied by u minus 4. And we're now seeing the problem as a product of one polynomial by another, which means that we know what to do. If we want to keep track of all the terms in this little table format, let's do it that way. So what that looks like is I'm just going to keep track of the products of the u's and the minus 4's, remembering that every term from the first factor has to multiply every term from the second factor. This actually is an instance of what's typically called FOIL. Multiply the product of the first terms, the outer terms, the inner terms, and the latter terms. So what's that look like? I'm going to multiply the u times u and give me a u squared. I'm going to multiply the minus 4 from the first term by the u from the second term. I'll multiply the u from the first term by the minus 4 from the second term. And I'll multiply the minus 4's from both terms by one another. Again, I should have 4 terms, keeping track of them in my little table. I've got a u squared, I've got a minus 4u, I've got another minus 4u, and then I have a minus 4 times minus 4, which gives me plus 16. So already we can see that this is a little different than just distributing that power. If we just distribute the power, we miss out on both of those terms that are minus 4's times u's. So we're missing something. We've accounted for all the terms that we need to account for. Now it's just a matter of simplifying. Are there any like terms for me to simplify? And the answer is yes. We have a pair of terms that have a variable factor of u to the first power. We have negative 4u minus 4u. Another common place for people to screw stuff up here is to accidentally cancel those two terms. But it's not cancellation that we need here. It's combination of the coefficients. Negative 4 minus 4 is not 0. But is in fact negative 8. So when the like terms are combined in this product, we end up with u squared minus 8u plus 16. And that is going to be our final answer to this problem. So almost more important than remembering what to do in a problem where you take a power of a polynomial is remembering what not to do when you take a power of a polynomial. Do not distribute a power, an exponent, across across addition or subtraction. Powers do not distribute across addition or subtraction. And we can see here explicitly why that's the case. If we just distribute the power, we miss out on that minus 8u term that's in the middle. So distribution does not work when you have addition or subtraction on the inside and a power on the outside. So instead, turn it into a multiplication problem. Completely forget about the exponent by rewriting the square as a multiplication of that polynomial by itself. Once we know that that's what we're doing, multiplying a polynomial by itself, then that unlocks our strategy. Distribute multiplication over addition, which in this case is an example of what's usually called FOIL. Multiply the first, the outer, the inner, and the latter terms that you see, and then simplify the results.